So you're looking at a massive HVAC system in Saudi Arabia. Ever wonder what it really takes to get it from installation to fully operational? It's not just about flipping a switch, believe me. It's this intricate dance between local codes and global standards, and in this quick explainer, we're going to break down exactly how that dance works.
Okay, so here's how we're going to tackle this. We'll start with the biggest challenge, just getting all the codes to play nice. Then we'll walk through the design and prep phase, jump into the hands-on system testing, and finally, we'll cover the paperwork that wraps the whole thing up. Let's get into it.
All right, let's get right to the heart of it. The #1 challenge on any major project in Saudi Arabia is this. You're not just following one rulebook. You've got to perfectly blend the local requirements, which are totally non-negotiable, with international best practices. It's all about weaving them together into one seamless strategy.
So this is the question, isn't it? For any engineer or project manager, this is what keeps you up at night. How do you take all these different standards with their own priorities and make them work together on a single, compliant HVAC system? Well, let's figure that out. You know, the complexity really hits you when you see who's involved. You've got the Saudi Building Code, the SBC, that's the law of the land. Then you have client-specific standards from giants like Aramco and the Royal Commission. And on top of all that, you're layering in the international heavyweights, ASHRAE for design, AHRI to certify the gear, and SMACNA to make sure the air balancing is spot on. It's a crowded room, and you have to make everybody happy.
So, with all those different players in mind, where do you even start? It all begins right here, in the design and prep phase. This is where you build the foundation for everything. Get this wrong, and you're going to be paying for it big time later on. And here's the single most important rule for this phase. Compliance is not something you tack on at the end. It has to be baked into the system from the very first calculation you run. Seriously, think of it like the project's DNA. It has to be there from the very beginning.
Now this table, this is basically your cheat sheet. It shows you exactly how different tasks map to different codes. You're doing cooling loads, you're juggling ASHRAE and the SBC. Looking at chiller performance, you've got AHI standards sitting right next to specific Aramco rules. This is your guide to getting the design right.
And all those calculations lead to critical design targets. A perfect example is your chilled water temperature differential, or delta T, often set right at 10 degrees Fahrenheit. This one little number dictates so much: energy efficiency, pipe sizes, you name it. And it comes directly from those standards we just talked about. Okay, before you even think about starting this thing up, you've got to run your pre-commissioning checks. Think of it like a final pre-flight inspection. Mechanically, you're making sure pipes are clean and can take the pressure. Electrically, you're checking that the power is right and the motors spin the correct way. And of course, you're making sure the brains of the operation, the building automation system, is actually talking to everything. All right, the prep work is done. Now for the fun part, finding out if all that design work actually, well, works. Welcome to phase 2, where the rubber really meets the road. So testing really breaks down into 2 main fields. You've got the water side, which is like the heart and arteries of the system, the chiller making cold water, and the pumps moving it around. Then you've got the air side, which is like the lungs, making sure the right amount of fresh, cool air gets to every single room. And speaking of the water side, this is a huge one. Your piping systems have to go through what's called a hydrostatic test, usually at 10 bar or 1.5 times the operating pressure. This isn't just a suggestion, it's a mandatory safety check, spelled out by folks like Aramco to make sure nothing is going to leak or burst when you go live. Over on the air side, this chart pretty much says it all. The whole goal of air balancing is to measure the actual airflow coming out of every vent and make sure it matches the design. So the conference room isn't an icebox while the corner office is an oven. It's all about precision and making sure what was designed is what was delivered. So the system is installed, it's tested, it's balanced. Awesome. But you are not done. Not by a long shot. Now we've got to get through the final and, honestly, one of the most critical phases: documentation and closeout. And here's the deal. You could have the most efficient, perfectly running system on the planet, but if you don't have the paperwork to prove it, it basically doesn't count. You need to assemble a whole package of proof: the inspection plans, the official reports, the certified balancing data, all of it. This is the paper trail that proves you did your job right. So closeout is way more than just being done. It is the formal process of building your case. This is your final exam. It's the moment you prove, on paper, that your system hits every single mark required by all those local and international standards we talked about from the very beginning. And that kind of brings us to one last thing to think about. These codes, they don't stand still. They're constantly changing. So the real test of great commissioning isn't just passing today's inspection. It's creating a documentation package that's so solid, so clear, that it's ready for whatever comes next. Is your work future-proof?